Chapter 6, Section 3, Antiderivatives. First, we're going to talk about the rules for definite integrals. You should have a sheet with 5 rules for definite integrals, and we're going to use those to do exercise 2 on page 294. In this exercise, there are some given facts which I'll write down when we need them. Part A, question 2, part A, page 294, says the integral of -2 times f of x dx from 1 to 9. One of the rules for definite integrals is when a constant is multiplied to the function, in this case -2 times f of x, we will always move the constant, in this case -2, to the left of the integral symbol. So that's one of the rules on your sheet. The -2 constant multiple moves out to the left of the integral sign. Then that -2 just gets brought down, and the integral of f of x dx from 1 to 9 is -1. That's given. Look at the exercise and you'll see that this entire fancy expression is equal to -1. This is multiplication, so the answer to part A is 2. Number 2, part B, it says the integral of f of x plus h of x dx from 7 to 9. Another property of integrals is when the integrand, here's what I mean when I say the integrand, when the integrand is more than one term, we are allowed to distribute the integral symbol. This becomes the integral of f of x dx from 7 to 9 plus the integral of h of x dx from 7 to 9. We're just taking the symbol and distributing it to each term. The dx also gets distributed backwards, so each term here gets a dx. Then simply from the directions, this integral of f of x dx from 7 to 9 is 5, plus, bring it down, integral of h of x dx from 7 to 9 is 4. Just getting these from the directions. So the answer to exercise 2, part B is 9. That's it. Next one is number 2, part C. It says the integral of 2 f of x minus 3 h of x dx from 7 to 9. This combines the two properties from parts A and B because the integrand always means whatever is in between this symbol and this symbol. Whatever is in between here, integrand. In this case, the integrand has 2 terms, so we're going to distribute and make 2 separate integrals. We're going to write the integral of 2f of x dx, because the first term is 2f of x. So 2f of x dx. The 2 is a constant multiple, so there, to the left of the integral symbol. 7 to 9. And then minus the integral of 3 h of x dx Notice the 3 is a multiple, constant multiple, so it's written to the left of the integral symbol. And then we just get values from the directions. The 2 gets brought down. The integral of f of x dx from 7 to 9 is 5. This indicates multiplication. In the step above, copy the minus, copy the 3. The integral of h of x dx from 7 to 9 is 4. 10 minus 12. The answer to part C is negative 2. Part D. Well, first of all, the following is given in the directions. This is in the directions. The integral of f of x dx from 1 to 9 is negative 1. One of the integral properties on your list there says if we have the same exact integral, except switch these, put the 1 from up there, from down there to up there, and move the 9 down there, move it from up to down, that has the effect of multiplying by negative 1. So in other words, this is equal to the negative of the integral from 1 to 9 of f of x dx. You'll see this property. It's the actually first property on the list. So exercise 2D says, what is the integral of f of x dx from 9 to 1? It's going to equal this negative comes down, and from the directions, that's negative 1. Negative, negative 1. So 1 is the answer to number 2, part D. Number 2, part E. It's the integral of f of x dx from 1 to 7. That's the question. So I see in the directions the integral of f of x dx from 1 to 9 is negative 1 in the directions. I also see the integral of f of x dx from 7 to 9 is 5. So we take this integral that I just wrote, switch these limits, they're called the limits of integration, switch them, put the 7 up here and the 9 down here. If the integral from 7 to 9 is 5, the integral from 9 to 7 must be negative 5. Then we look at the last property on your list of rules, the integral of any function from a to b, a and b, any two numbers. If we add to that the integral from where this one left off, this one went, we say this one goes from a to b. If we add an integral that starts at b, where the previous left off, and goes to some other number c, we can put this together to make one integral from where this first one starts to where this one ends. That's the last rule on your list of rules. So to make this fit the part we're doing, part E, we say the integral from 1 to 7 can be written as, can be split up sort of as the integral from one to some number, let's say 9. You'll see why I chose that number. Plus the integral from where that one left off. This one left off at 9. And I want to go to 7. These are not necessarily in any order. You might think it's weird to go from 9 to 7, but we do that sometimes. We might call that going backwards. But that's how we say it. We say the integral from 1 to 7 can be split up by going from 1 to 9 and then picking it up from 9 and ending up at 7. As long as these match. This one up here, 9, matches this one down here, 9. C matches, B up here matches the B down there. And the A and the C are in the result over here. In this one, the 1 and the 9 are in the result. I meant to say the 1 and the 7. Sorry. So the integral from 1 to 7 is whatever that integral is, which is in the directions, plus this, which is -5. Do you know why that's -5? Look back and you'll see. Final answer, -6. This was part E. So what's written here is the rule. It's one of the 5 rules. A, B, B, C becomes AC. This is using that rule with, instead of A, B, and C, it's using 1, 9, and 7. Think about it. All right, there's one more part to this question. It's number 2, part F. The integral of h of x minus f of x. H of x minus f of x is the integrand, integrating from 9 to 7. Well, first thing we think of doing is distributing the integral sign. So the integral of h of x dx from 9 to 7, then a minus integral of f of x dx from 9 to 7. So do I know the integral of h of x dx from 9 to 7? It's -4. I hope you know why it's -4. Look at the directions and look at stuff we've done. This minus gets brought down. The integral from 9 to 7 is -5. Do you know why? So -4 minus -5 is 1, and that's the answer to part F. All right, so now we're going to talk about the antiderivative. All of these were learning the rules for definite integrals that are on your handout. Now we're going to talk more about the word antiderivative. And we're going to try to learn it by doing page 295, exercise 20. It says the integral of cosine x dx from 0 to pi over 2. This is read the integral of cos x dx from 0 to pi over 2. From now on, when we write this symbol, we can either say integral, as I've been saying, or we can say antiderivative. You'll understand why eventually. So the antiderivative of cosine x dx is sine x plus c. When we say the antiderivative, we mean the derivative of this is the integrand. And the c represents any constant. It could be 5, it could be pi, it could be 7, any constant. Because the derivative of sine x plus any constant is cosine x. For the sake of the exercises we're going to do on page 295, this really can be any constant, but we're going to use 0 every time. And if you want to experiment, you'll see that when we get answers to these, even if you used a different constant here, like 12, the final answer will come out the same anyway. So we're going to use 0 every time to make it easy. So I'm going to start number 20 over again. Number 20. It's the integral, or I could say antiderivative, of cosine x dx from 0 to pi over 2. First I write the antiderivative of cosine x, and we're going to say it's sine x, because the derivative of sine x is cosine x. Then we're going to attach a bracket to that, just a closing bracket with these numbers attached, pi over 2 at the top and 0 at the bottom. When we attach the bracket, what that means is replace x with whatever number's up at the top, then replace x with whatever number's down there, 0 in this case, and always put subtraction between these. Try to understand why we do this eventually, but right now we're just doing it. The sine of pi over 2 is 1, the sine of 0 is 0, so the answer to exercise 20 is 1. If you don't get it, you're going to do a few more and you'll eventually see this is pretty easy. Number 22 is next. It says the integral of secant squared x dx from 0 to pi over 4. When I see this, my brain says, what is the antiderivative of secant squared x? And the reason I write tan x is, this is important, the derivative of tan x is secant squared x. So tan x is called the antiderivative of secant squared x. And we put a bracket, pi over 4 attached at the top, 0 down here, which means the next thing you write is tan with the pi over 4 in place of x, minus, always minus, tan 0 in place of x. And everybody knows the tangent of pi over 4 is 1, and the tangent of 0 is 0, so the answer is 1. Next one is number 24. Still on page 295. The integral of 3x squared dx. From negative 1 to 2. The 3 is a multiple. It's a constant multiple. So it's a reflex. Take the constant to the left of the integral symbol. You have a sheet of integral formulas, not the one that says rules for definite integrals. There's another sheet that says, that has no title, it's integral formulas. And the second one on the list says the integral of x raised to any number, like 2, dx, is always going to be x raised to this exponent plus 1 over n plus 1. If it's any constant, this formula only applies if the n, the exponent here, is not negative 1. If n were negative 1, we'd have division by 0 here, which is impossible. Bring down the 3. The integral of x to a number, dx, is x to this number plus 1 over the same thing I just said. Plus c, any constant, we're going to use 0. Put a bracket, 2 up there, negative 1 down there. Before we plug in these numbers, you should notice these 3's cancel, which means the 3's, this 3 up here and this 3 down there cancel. So we just have x cubed with the bracket attached, and the numbers are 2 up here and negative 1 down there. This tells me to replace x with 2. Replace x with negative 1, subtraction between them. So we have 8 minus negative 1. Final answer is 9. That was number 24. Let's do number 26. I want to say one comment about the last one. The reason we ended up with x to the third here, before we plugged in the numbers, is because, very simple, the derivative of this is the integrand. Isn't that true? Isn't the derivative of x to the third 3x squared? That's why we say the antiderivative of 3x squared is x cubed. So we use this formula to end up with it. So back to number 26, the integral of 8 dx from 3 to 7. The 8 constant multiple goes to the left of the integral symbol. Look at your list of integral rules. Not integral rules, integral formulas. The very first one looks like this. So as 8 gets brought down, the integral of dx is just x plus any constant. We're using 0. So why do we say the antiderivative of 8 dx is 8x? I hope if I ask you this in class, you'll say the reason is because the derivative of 8x is 8. So the antiderivative of 8 dx is 8x. The 7 and the 3 means we write 8 times 7 minus, always minus, 8 times 3. 56 minus 24 is 32, and that's the answer to number 26. Now we're going to number 28. The integral of 1 over radical 1 minus x squared dx from 0 to a half. I'll come back to this in a second, but I want to show you one of the formulas that's on your sheet. You will need to memorize these eventually. The second last formula says the integral of dx over the square root of a squared, a meaning any constant, minus x squared is the arc sine of x over a plus any constant. This a in this formula represents any constant, so a squared could be 1, a squared could be 9, a squared could be 12. I'm going to see what happens when a squared is 1. I'm sliding this dx over here to make it look like the problem. This is the arc sine of x over a. If there's a 1 here, then a is 1. The exercise we're doing, number 28, has this exactly. So we're going to replace all that stuff with that. C means any constant. We're going to use 0. So arc sine x over 1 plus c. C is 0. Bracket, half up there, 0 down there. That means this is what we write next. The arc sine of the number up there minus the arc sine of the number down there. The arc sine of a half means the angle whose sine is a half. The arc sine of a half means the angle whose sine is a half. Everyone knows the sine of 30 degrees is a half. And everybody knows the arc sine of 0, angle whose sine is 0, is 0. It's the final answer of 5 or 6. Right, one more formula before we end this segment is there's something called the average value of a function. The average value of a function on a given interval. From a to b, from some number to some number. If the function is called f of x, f with a bar over it would be the symbol for the average value of the function. Some people use f with an AV subscript, meaning the average value of the function. It's always 1 over b minus a. These numbers would be given, this interval, times the integral of the function dx from a to b. So a formula to know by heart, the average value of the function. F bar, 1 over b minus a times the integral of the function from a to b. Page 295, exercise 32, it says y equals 1 over x squared, and there's an interval. Sorry, it doesn't say y equals 1 over x squared, it just says y equals 1 over x. And there's an interval from e to 2e. From this number e to this number, 2 times e. The question is, find the average value of this function. The symbol could be y with a bar on top. It's 1 over b minus a, that would be this number, 2e, minus this number, times the integral of the function dx from e to 2e. And we're just using this formula. 1 over b minus a times the integral of the function from a to b. 2e minus e is e. The integral of 1 over x dx, get your formula sheet and you'll see that it's this integral right here is the natural log of the absolute value of x. This is the third formula on your sheet. The plus any constant, do 0. Put a bracket here with 2e up there and e down there. This thing in front, the 1 over b minus a just gets plugged on. The bracket notation means we're going to replace x with 2e, make the subtraction symbol, and then replace x with e. Like this. 1 over e times the natural log of the absolute value of 2e minus 1 over e times the natural log of the absolute value of e. But 2e is positive, and so is e, so the absolute value symbols are not necessary. And the 1 over e that's in both is I'm going to factor that out. 1 over e times the natural log of 2e minus the natural log of e. Go up here now. We need a pen to hurt. 1 over e is out in front. A log minus a log can be written as 1 log of the quotient. I'll repeat, a log minus another log can be written as the single log of the quotient. That means we now have 1 over e times the natural log of 2. And we're going to call that the final answer. The textbook gives the answer like this, the natural log of 2 over e. Same thing. This one is number 34. Y equals 1 over 1 plus x squared. And we have the interval from 0 to 1. The question is find the average value of the function over this interval. The average value of the y is 1 over b minus a. It would be 1 minus 0. This is the a and b right here. And the integral of the function dx from a to b over 1. Well, here 1 over 1 minus 0, that's just 1. And this integral, or antiderivative, is very last one on your formula sheet. The formula sheet has an a squared plus x squared, so the a squared must be 1. So according to that last formula, this integral is 1 over a, by a I mean the square root of this number right here, times the arc tangent of x over a, the a is 1, because that's a squared, plus any constant, and we're going from 0 to 1. Y bar is the arc tangent of, replace x with the number up here, minus the arc tangent, replace x with the bottom number. The angle whose tangent is 1, everybody knows that's 45 degrees. The angle whose tangent is 0 is 0. So pi over 4 is the answer. And we're going to do one more, number 36. Y equals secant x times tan x. The interval is 0 to pi over 3. We're going to find the average value of this function in y bar. It's 1 over b minus a, b minus a and b are given, times the integral of the function. Don't forget the dx, from 0 to pi over 3, or in general from a to b. 1 over pi over 3 is the same as 3 over pi. And this integral is fourth one from the bottom. I think it's the 9th one from the top. The integral of secant x tan x dx is secant x. Remember, the reason for this is it's correct formula because the derivative of secant x is this integrand. So when we have this symbol for the antiderivative, it's secant x. The fourth formula from the bottom of your list, which says plus c, but c is any constant. And I'm going to attach a bracket here with pi over 3 up at the top and 0 down here. So that tells me to replace x with pi over 3, then make a subtraction symbol, and then replace x with 0. Pi secant x. That's where we thought the two numbers are 0 and pi over 3. So the average value of the function is 3 over pi times the secant of pi over 3 minus 3 over pi times the secant of 0. Pi over 3 is 60 degrees. I know the cosine of 60 degrees is 1/2. That makes the secant of 60 degrees reciprocal of cosine. The cosine of 0 is 1. That makes the secant of 0 the reciprocal of cosine. The reciprocal of 1 is 1. Three over pi times 2 is 6 over pi, minus 3 over pi times 1 is 3 over pi. This fraction minus this fraction, just subtract the numerators, keep the denominator, and this is the final answer. That's called the average value of the function on the given interval. The end.